founders of DataStax. How many of you were here for the Cassandra Summit 2 years ago, the second one ever? A few in the back? Well, then you guys know where this is coming from. The lightning talks really gained their glory at the second Cassandra Summit ever that was across the bay. And Matt Dennis really brought those to life. There was, at the end of the day, to close it out, and there was a lot of fun to be had, and we're going to keep that tradition going. We have 10 speakers today. They're going to cover a topic around Cassandra in under 5 minutes, and the only rule is when 5 minutes hits, it's game over. So to kick things off, we're going to start with John Bush, and he's going to talk about scaling Cassandra with SSDs.
Hi, folks. I'm Vice President and Senior Fellow from SanDisk Corporation, and I'm going to talk to you today about SanDisk software technology that allows you to get order of magnitude increases in performance on your servers, on your clusters, deploying Cassandra with SSDs. A little background, I was Vice President, I headed up computer research at Sun Microsystems for 7 years. And we invented the multi-core processors there, used flash memory. And I was very disappointed that we couldn't achieve the potential of those when it was deployed with real applications. Worked with eBay, Amazon, and such, and they were only getting small fractions of the potential factors improvement versus order of magnitude. And so we invented the technology. I started a company called Schooner, and we invented the technology that could fully exploit multi-core processors and flash memory. And I merged the company with SanDisk last year, and I want to show you what we've done integrating that technology with Cassandra. So what you see here is, in the top right corner, is if you're running a small data set in memory, 14 gigabytes, the best performance you can get from Cassandra, third column, is about 80,000 transactions per second. As the data set size increases to half the size of DRAM, actually the in-memory performance of Cassandra drops in half. On this left side is Cassandra with 1 terabyte of flash running on hard drives, and you see you lose 98% of your performance. This second bar shows you if you put in a popular PCIe flash, store your terabyte on flash, you get about 25,000 transactions per second. When we integrate this SanDisk software technology with Cassandra on that same hardware, same server, we achieve 95,000 transactions per second. This is resilient across workloads, whether you have high write rates, whether you're in clusters with 3-array replication, we're seeing this uniform across the board. What does this mean to you? Well, what it means is when you and your customers deploy Cassandra in flash-based configurations, you're going to be able to have 1 server versus 6 if you use 750 gigabyte Dell 720s with DRAM, or 34 servers with flash, with dramatic reduction in power, with dramatic reduction in total cost of ownership. A little bit about SanDisk. SanDisk is a $5 billion revenue company. So half the flash in the world is shipped by SanDisk. SanDisk basically invented flash technology 25 years ago. And SanDisk is committed to bringing the benefits of flash broadly to data centers, to bring these kind of benefits. SanDisk spends $650 million a year on R&D to make that happen. SanDisk has complete top-to-bottom capabilities. SanDisk invents the circuits, the NAND circuits. SanDisk does the manufacturing. SanDisk delivers SSDs. SanDisk provides optimized software like I've shown you today. What's interesting is as we're doing these new technologies with the software, we're able to provide not only caching, initially we replace SSDs, but then as we introduce new software capabilities such as caching, such as the in-memory computing I just showed you, and as we introduce 3D technology, the use cases of flash across the data center will just continue to grow. So what I want to tell you is that SanDisk, this Cassandra optimized, flash-optimized technology with SanDisk technology. We're bringing this to market, working with DataStax, working with the community. We want that to be available to you and your customers this year. There's no changes in applications required, no special servers. Works with all flash technologies, PCIe flash, SATA drives. In fact, the benefits I showed you are basically 100,000 transactions per second versus 10, 15,000 transactions per second are available no matter what flash technology you deploy. We have a booth out here, and our architects, our chief architects, our business partnership people are there. We'd love to talk with you and see how we can bring these solutions to your data centers. Thank you.
Thank you, John. And next up, we have Yuki Morishita, an Apache Cassandra committer, and he's going to talk about how to contribute to Apache Cassandra.
Hi, my name is Yuki. I'm an Apache Cassandra committer and working for DataStax. And today, I want to really quickly talk about how you can contribute to Apache Cassandra project. Either you can write the code, or if you don't write code, there's other way you can contribute to the project. So here's a guide for the programmers. First, you have to equip these tools to begin writing the code. We use Java SDK, Apache and Git for source code management, and we use Python for various scripting. And here's a Jira hosted on Apache Software Foundation. And we use this to submit bug report or any kind of feature request. And of course, anyone can create an issue from here. So if you haven't taken a look at it, please do in the future. So first thing, you have to get the code from the Git. And there are a couple of links that host the Cassandra source code, but the one in the above is the original one. So please make sure to get the code from here. And to build a Cassandra, it's really easy. Just type ant from your terminal, and it does its job. And you can write your code with your favorite editor or IDE. Just follow the coding style posted on Wiki. And if you're done writing the patch, just make sure you don't break anything by running ant test. This will run all unit tests we have in Apache Cassandra. So, but wait, isn't Cassandra a distributed database? So how do I test Cassandra in distributed manner? And there's a tool called CCM that manages Cassandra cluster on your computer. So you can, as you can see, you can launch 3-node Cassandra version 1.2.5 cluster within a minute. It is hosted on GitHub, and the nice thing about CCM is you can use that to script your own test suite. So here's a stupid example to just list all the nodes, but it is really nice to have this kind of tool. And in fact, we have a distributed test suite called Cassandra DTest, and it is also hosted on GitHub. So if you want to take a look at it, you can just clone the Cassandra DTest from GitHub and just run node test. So this will create the Cassandra cluster on your computer and do the distributed testing. But it takes a long time. So we have set up a continuous integration site in our web server. So here's a link, and maybe you can take a look at it later. To create patch, just use a git command to create patch and upload it to Jira. And please don't forget to press the submit patch button. And so far, I talked about Cassandra contributing guide for programmer, but there's a lot of things you can do if you don't like the program. So things like bug reporting, you can use Jira to create an issue, or anybody can be a reviewer or tester. It is not an exclusive committer club, so feel free to contribute. Feel free to grab the patch and test in your environment. And it is really nice to hear your experience of Cassandra to the community. So blog it, tweet it, and get listed on Planet Cassandra. There's a lot of user list and 5-minute interview there. So please feel free to tell your story to the world. So that's about it. And if you have a question, you can always ask on IRC or post it on mailing list or tweet about it. Or you can directly mail me at that address. So thank you very much.
Thank you, Yuki. And to add to something he said, he mentioned planetcassandra.org, and there is a website. If you're using Cassandra and would like to have your use case listed to help the community, please visit that or just email me, Matt, with 2 T's at datastax.com, and we will set that up quickly. It's really good to give back to the community. Up next, we have Nate McCall, very famously known as ZZ Nate on the Twittersphere, and he will be talking about adding your own thrift method in under 5 minutes.
All right, I'm going to admit to blatantly copy and pasting this slide, first off. So this was a slide deck I did recently, hacked in this. But what I'm talking about is working on, well, first of all, I'm Nate. I go by ZZ Nate on IRC and Twitter, et cetera. I work for Apigee. So the Cassandra API does everything I want. No one ever said that, which is fine because, you know, like anything, for any job, there's the right kind of tool you should use. And I've gotten interested in this because there is, one of the things we do at Apigee is we do a lot of, we've been doing a lot of custom work with Cassandra. So one of the things we do all the time is send a lot of huge multi-kits. And that can be complicated. We do roll-ups on the client side, and it gets more and more complicated as we go forward. So one of the things we start experimenting with is how to roll stuff like on the server to cut down the workload and cut down the network transfer. So there's a lot of options for CQL, Thrift. Why create something new? The common client patterns emerge. Union operations, aggregations, filtering, joins, round trips required. You got redundant data on insertion. So these can be wasteful and cost a lot of CPU and a lot of memory, both over the wire and where else. So the way to cut down on those, you can move some of the things into the server. So in general, what you have here is Thrift. One of the biggest issues is that sometimes it can be a little bit hard to understand what's going on with consistency levels and everything else. CQL, it's great, but need tools. Work great with tools. For those of us who've been using Cassandra for a while, it's not quite what we want to do, or it doesn't hit the use cases you want, particularly if you have dynamic column families. So we get into, I thought I took that out. Binary protocols with idiomatic clients misses the market, in my opinion and in my experience. So that stuff's not interesting to me, so we tend to hack deeper into transports. I like writing Java apps, but for most popular application frameworks these days is HTML5. So one of the things we do is experimenting with sending JSON directly into the server to see if we can get some efficiency gains there. And therefore, we get into hacking transports. So to show you how to do this real quick, in under 5 minutes, you implement Cassandra server, CassandraDemon.server. There's 2 methods in there, start and stop. They're pretty easy to override. And you can do whatever you want in there. What we've done is mess around with Vertex, particularly, and fire up a Vertex transports to do HTTP. I have some links at the end of this to show you where all the code is. I was going to try to do a demo, but I didn't realize we were kind of in a canned format here, so I had to change that at the last minute. Extend Cassandra daemon. There's a main setup, start and stop in that one. Again, those are pretty easy to do. You can call super on most of those and do whatever you want. Configurations, some handy ones to know is that you can turn off or turn on foreground logging and log4j, just keep the thing in process. Turn off the log4j overrides and where the configuration file lives, so you don't have to have log4j-server or whatever. You can turn off and turn on the other 2 transports, RPC and the CQL transport. Configs, there's this one, configs, the RPC and the native transport. You can turn on and off. So that's the end of it. The code I was going to show is at the GitHub address. You can take a look at it. What it does is just really simple. That overrides those things, and you run it with Maven exec. Oh, there's one thing I forgot to mention on there, which there's another configuration property in Cassandra env shell script that you need to point to the daemon. But it's really easy to do. It's kind of an undocumented plugin mechanism, and it's exactly how DataStax Enterprise works, or used to work, by firing up the daemon. And Preem works this way as well, by launching their own daemon. So there's a couple examples out there of how to do this. It's pretty fun to do, and you can go directly into the storage proxy API. Sort of do whatever you want and get some real efficiencies by doing that. I guess that's it. See me afterwards if you have any questions. Thanks.
Thank you, Nate. And again, Nate is ZZNate on Twitter, longtime community helper for Cassandra. Up next, we have Cathy Chang, and she's going to talk all about different ways that you can leverage big data and common practices involved with that.
Thank you, Matt. So, Cathy Chang, Senior Director of Business Development at Impetus, and today I'll talk about proven practices in leveraging big data's competitive advantage. A little bit about Impetus. It's consulting and services leader for big data, headquartered in San Jose, and 1,400 plus engineers with presence in the US, India, and over 200 of our folks focus on big data specifically, 80 of them dedicated to R&D. One of the examples of innovation coming out of our innovation lab is Condera, which is annotation-based Java library for NoSQL technologies such as Cassandra. So the practices for competitive edge. We take a data science approach, and we have real-time search, alerts, and analysis approach, as well as visualization and business intelligence practice. First, data science approach. Drill, assess, target, analyze, recommend. What is that? So that's our process, that's our approach. We drill into incoming question, assess goal-driven hypotheses, target data collection, analyze hypotheses, and recommend summary of results and action items. So that is a taste of what our data science approach looks like. So here's a few focus areas we've been able to achieve with our data science and machine learning approach in this space. Some of the algorithms that we have, machine learning algorithms that we have been using. So next is real-time practice areas. So with this, we focus on search, alerts, and analysis. Some of the areas are listed here. And we were able to implement some highly scalable distributed architectures using technologies such as Esper, Kafka, Storm, and Akka in the space. Notice Hadoop at the very right bottom. That's not real time, but it is part of the process where we use it as a storage as well. So NoSQL is right before it, and Cassandra falls in there. Here's a high-level snapshot of a use case with Cassandra. We were able to help a large telecom customer to fulfill their requirements of high-speed ingestion, real-time analytics, as well as high geographically distributed data replication with Cassandra. So what we have been able to do was not only to help them understand that they can use open source technologies, but also exceed their expectations with how they can use those options. With data science approach and real-time practices, the bar is set pretty high for visualization and BI practices. Our exploratory analytics involves bringing data in, correlating it, aggregating it, and visualizing it. Here's a sample of what it looks like in terms of a report, drill down, and delivery. And we have developed a customized scoring matrix to evaluate the pros and cons of different technologies and vendors and be able to put weighting and different criteria in this fashion. We not only use this for visualization and BI practices, but for all of our practices. So given that, the data science approach enables a data science workbench. We also accelerate data ingestion to insights to action with real-time analytics framework. And we empower decision makers with true insights through exploratory analytics and intuitive visualization. So with those, we help you accelerate your data to value wherever you are on the data journey. So thank you, and Impetus, again, provides vendor-neutral consulting services. We take enterprises through the journey of successful big data option. We have our booth out there. A number of architects are here as well. And you can contact us at bigdataimpetus.com, and we're hiring. Thank you very much.
So question for the audience. How many of you have ever used Eventbrite before? There you go, good show of hands. Up next, we're going to learn all about how Eyal Reuveni, a software engineer at Eventbrite, and how they use Cassandra in action.
Thanks, Matt. My name is Eyal Reuveni. I'm a software engineer on the spam and fraud team at Eventbrite. For those of you that haven't used Eventbrite, Eventbrite is a self-service ticketing platform that allows anyone to be an event organizer and create an online presence for their event. So we've been more focused traditionally on creating tools for our event organizers so that they can better promote and sell their events. So those have been tools like email marketing so that they can see how well their event invitations are doing, to tools like entry management systems so that when a user prints out a ticket and goes to the event, the organizer can scan that ticket and allow the user to get in. The thing, though, is that events are an inherently social experience. They're live. You go with your friends. You meet new people. You make new connections. And we really wanted to mirror that experience on Eventbrite. And so we, in the past year or so, have been creating more and more new features that integrate this deep social experience with Eventbrite. And all those features have been powered by Cassandra. So anytime a user receives an email notifying them, hey, 2 of your friends are going to this really awesome event, and we think you should check it out, that's powered by Cassandra. Anytime a user opens her iPhone and sees her list of recommended events on the Eventbrite attendee app, that's powered by Cassandra. Anytime a user goes to an event page and sees which of their friends are going to this event, that's powered by Cassandra. The reason we chose Cassandra is that we have kind of a simultaneous workload going on here. So we have a background process that asynchronously is sending all these emails out, and they're sending millions of emails out a month. But at the same time, we have to serve all this data, hundreds of requests per second on our event page. And our event pages are the ones where we make all the money, so we have to make sure that it was scalable. And now, in the past 2 quarters, we've started moving more and more things to Cassandra in addition to our social effort. And all that's been because Cassandra is really flexible and really easy to use. And it's actually really cut down on our development time. So I'll give you an example. This user activity auditing was actually a system that we've had for a long time. It goes and basically it keeps track of password resets, failed logins, things like that in case of account takeovers. So that was an old system that we had that was built in MySQL. It was clunky. It took a really long time to query the data. So a single engineer spent a month learning Cassandra, rewriting it, bringing it up to production, and it's been working great since. I'll give you another quick example. This little screen capture here is a little tool that I wrote as a side project. Basically, we needed a way to query our production and Cassandra data because we can't log into those systems. So I spent about half a day just kind of hacking around with this and put it up. And I think I spent most of the time actually futzing with the JavaScript. So it really has been great. So Cassandra is a really central part of our architecture. It's one of the only systems that touches all the others, from the website to Java and Hadoop to all of our mobile applications. So we've definitely been relying on it as a platform for the past year. That being said, though, there's definitely the right applications that you have to build on top of Cassandra. So everything that we've done with it has to be resilient to any sort of data staleness or timeout issues. So for example, on our event pages, if we can't get the full list of your Facebook friends that are attending that event, then we'll show maybe one from 30 minutes ago, and that's okay. But we have found more and more use cases for Cassandra because it really is a great database. And as you can see here, in about a year, we're using it significantly more than MySQL. And we've been loving it ever since. So thanks.
Thank you for that. Up next, we're going to learn all about how security changes when it comes to big data with Joey Jablonski.
Great, thank you. Hi, everybody. I'm Joey Jablonski. I'm in the product management group at Dell. I'm responsible for a variety of products related to data integration for NoSQL, for Hadoop, products like Katinga that do natural language processing. Not going to talk about any of those products today, I promise. But I want to talk about security within these big data environments, where we're seeing quite a dynamic change. And if we really want to overcome this hurdle of gaining the enterprise adoption, kind of the largest of the large Fortune 500s, these are the types of questions they start to ask. They start to ask, how do you touch all these other business systems, all these other IT environments to ensure that you're part of our larger enterprise? So what we're seeing today is that when we start deploying technologies like Cassandra, Hadoop, next to our Oracle relational databases, all these other random technologies, we end up with this large problem of sprawl as it relates to security. That moving data around becomes a very large, complex problem. We don't know who has access to what. We don't know what users, what groups we have. Suddenly we have a diverse set of different applications accessing a diverse set of different data sets with different access credentials, things like that. If you're the software development team, if you're the IT department, this becomes very easy to understand. It's language you understand, it's terminology, it's technology that you work with. If you're the legal department, the security department, some compliance organization, this becomes a big problem. Not because it is, but because it's fuzzy and it's hard to understand. So they start to ask questions of, how do you prove who accessed our data? How do you prove that it's not being accessed by the wrong entity? Those sorts of questions. So this falls on us as a community to resolve as we continue to evolve the applications and the software we've developed in this space, as we continue to implement larger and more complex environments using these technologies. There's a lot of things that we have to do to make sure that these security departments, these larger organizations, can be compliant and can lower that stress level, that barrier to adoption. Because at the end of the day, it doesn't matter how good our technology is, it doesn't matter what shiny new features we put. When we get to larger organizations, if they don't buy into this, if the compliance departments, the security organizations don't bless it, we don't get adopted, and then we hurt as a community. So as a community, there's several things we can do to drive this and really get that comfort level up. First is that security context needs to be shared alongside the data when we're doing data movement operations. So I have ETL referenced here. We could have an argument all day long of if ETL is dead or if we're going on to new ways. But at the end of the day, moving data around is not going to stop. We're always going to have to move data between disparate systems to drive different applications, bring it in from our partners or from our customers. So we have to move data around. So it's important that when we move that data around, we carry the security context as part of it. We know who's allowed to access the data, what they're supposed to do with it. Can we send it outside the organization? This context, at the time that we move it, allows us to much more simply populate other systems at the time of population of this data. The next item is something I think we've probably been struggling with for 20 years, is identities have got to be consistent. We've got to make sure that if Joey is logged into two different systems, that's the same person. We need to know who's accessing this data. Otherwise, there's no possible way we can restrict back what they're doing. There's no possible way we can audit what they're doing. So we as a community need to make sure that we keep these consistent identities across all of our disparate data silos. This goes back to the first one. If we carry that context of who can access the data across the different systems, it suddenly becomes very easy to make sure that we're ensuring consistent policies are enforced. And then finally, this is a problem we're seeing more and more that we're going to have to address as time goes on, is this data plus data problem. a lot of the organizations that we work with, they have large amounts of data that is in the open environment, or they share it very widely internally because it's not sensitive. But the minute they combine that piece of information with another piece of information, it becomes very, very sensitive information, so we have to restrict back who it accesses. So as we start to look at new ways to classify data, as we look at new ways to restrict back and limit access on data, not only do we need to take into fact what the permissions on that single piece of information is, but how it relates to other pieces of information. We'd never want to end up in a situation where someone got a confidential piece of information through accessing two regular open forums. So we need to be conscious of that as we put data together. So as a community, it's going to be up to us. As we continue to implement these new technologies, as we do cutting edge work around new capabilities, we need to make sure that we focus on context of the data, identities, data plus data problems to ensure that we can drive adoption. We don't have compliance organizations telling us they don't want to take our technology. Thank you.
So I have a very quick trivia question for the crowd. Raise your hand if you know the origin of the name of the project Cassandra and why it is called Cassandra. 1, 2, a few in the back. You don't count, you heard from me. So this is deep, and it's good that you're all sitting down. In Greek mythology, there was someone named Cassandra, and she was cursed with the ability to see the future, but no one would believe her when she said what it was. The guys who created this named it Cassandra because it's the cursed oracle. Think about that for a second. Up next, we've got Brian Hawkins to talk about time series databases with KairosDB.
Thanks, Matt. Wow, that's a big screen. It's a Prezi presentation, so if the transitions make you sick, just close your eyes. Don't throw up on your neighbors. Now, I thought a way to tell this about, it's an open source project, and I want to tell a way to tell about this project is tell you a little story. So I'm going to have to read it because I can't do it otherwise. But this is Bob's story. This is Bob. This is this is the network Bob is in charge of. This is the application that is causing several of Bob's systems to become unresponsive. The problem is Bob has been unable to locate the application. Bob is constantly being asked by his boss, "Why is the system going down, Bob? What is the problem, Bob? And remember, Bob, we got to have new customers come on. You got to schedule capacity for that, Bob." Poor Bob. Poor Bob, the stress is taking its toll, and Bob is beginning to have dark, evil thoughts about pushing kittens off of bridges. But this is not who Bob is. He must find a solution to his problems. Bob spends days searching through log files in vain. Bob knows the metrics he needs. If Bob could just collect all the metrics into one place, he could correlate the data and find out what is going wrong. Where can Bob store metrics from hundreds, nay, thousands of machines? Bob consults the great Google. Now, Bob does spend about a half a minute thinking whether the government really is looking at his searches or not. Yeah. Bob learns the type of data he wants to store is called time series data. A time series is a sequence of data points measured typically at successive points in time spaced at uniform time intervals. Bob needs a time series database. And wouldn't it be great if that time series database ran on Cassandra? Bob has always had a thing for Cassandra. No, Bob, you don't have time for that, Cassandra. Again, Bob consults Google. Bob finds KairosDB. And it is built on Cassandra. Way to go, Bob. Kairos, what is Kairos? Kairos, an ancient Greek word meaning the right or opportune moment. Is this Bob's moment? Bob downloads KairosDB and within 5 minutes has Kairos running using the default in-memory data store. Bob quickly writes some shell scripts to publish the data to Kairos and begins viewing the data on the Kairos built-in UI. KairosDB provides data aggregators to combine the thousands of metrics his system will produce. KairosDB can also group the data by time, value, and tags that he associates with his data points. Eager to get started, Bob sets up a small Cassandra cluster, deploys his scripts, and begins gathering the data from his systems. Using the features in KairosDB, Bob is able to quickly identify the system and application that is causing his network problems. With KairosDB, this is Bob's moment. And with the data collecting in KairosDB, Bob is able to reliably predict resource requirements for new applications and customers. Bob has more friends now. Bob has more free time to pursue other interests in his life. Way to go, Bob. The end. And I think I was supposed to mention Netflix sometime. Some guy was going to pay me $5 for that. Anyway, no. So my name is Brian Hawkins. Jeff Sabin's over there. We work for Proofpoint. We started this open source project. Come talk to us afterwards if you have any questions about it. We'd love to talk to you about time series data and getting you on board. Just Google KairosDB. There's a GitHub project and it's on Google Source. So thank you very much.
And I'll reiterate, those are two of the more friendly guys in the community. They've been very helpful with anything we've asked of. Up next, we have Joaquin Casares, and he's going to do his introduction to DataStax Enterprise.
Yeah, so DataStax was founded in 2010, 3 years ago, by 2X Rackers. Together, they formed a business around Apache Cassandra, an open source database where committers from around the world test, fix, and maintain the key to tomorrow's future. Where conversations are actively spanning time zones in virtual space, where individuals contribute for free on their spare time or get paid by companies that are household names. Why? Because many are invested, many are in the same boat, many are relying on Apache Cassandra to transcend to the next level. Because today, we shouldn't have to worry about speed, size, complexity. Instead, we should focus on making things easier, better, saving the world. With Apache Cassandra, businesses are able to focus on what really matters. Conversations, music, games, movies, medicine, networks, banking, stocks, fire hoses, airplanes, instead of where data goes to sleep. Here are a list of companies that are doing this right now in production. This is all made possible due to a low-level hybrid in-memory architecture, a low-level on-disk stable architecture, a leading replication system that integrates with smart data center-aware routing, a simple interface that keeps getting simpler with SQL 3. What's best is it cannot be contained, not like Skynet yet. Simply add more nodes and it gets faster by accepting more writes, more reads, all in parallel. So companies no longer have to pay for large servers, expensive contracts, extra support, or stress out with multiple failures or epic failures that leave you and themselves in the dark. This allows companies to pay for innovation, not stress when a node's been offline all night, because you and these companies are all online. Google's Bigtable, along with Amazon's Dynamo, brought us Facebook's Cassandra 0.3. We're now at Apache Cassandra 1.2, and we're already looking forward to 2.0. This is a community-built database spawned from worthy technologies. DataStax Enterprise 1.0 continued with the same concept as before, make it simple enough to ignore, and we did. We merged Apache Hadoop on top of Apache Cassandra. Part of the merge was painful, but we did manage to rip out name nodes, secondary name nodes, Zookeeper, while job trackers and task trackers are managed internally, and we removed all of HSpace. This now sits snugly on top of Apache Cassandra. This allowed Apache Hive, Apache Pig, Apache Mahout to sit on top of Hadoop on top of Cassandra. We closed sourced this product in a bold move to make money, but not inconvenience the thinkers, the startups, the inventors. Instead, we produce enterprise software, consumed and continually improved for the large companies that feed the masses. Now, the bright, young, innovative startups that are in this room today only need to focus on making a mark on this world. DataStax Enterprise 2.0, we added Apache Solr, which implemented distributed search before distributed search was even possible in Apache Solr. How? By placing Apache Solr on top of Apache Cassandra. The leading open source search software was now capable of scaling larger than just one machine. And again, companies rejoiced, since no longer do they have to pay for expensive hardware, software, or maintenance, but instead on making things better, faster, and now searchable. But of course, this should not be taken lightly, since it's yours, mine, your mom's, your cat's, it's our data. DataStax Enterprise 3.0, we implemented another component, Kerberos, the open source network authentication protocol. Now we can protect your data by sectioning off tables, users, connections from accessing your data. The second component of DataStax Enterprise is OpsCenter, our cluster management tool, which is essential for day-to-day operations. You're able to visually see all your metrics over time and across clusters. The third and final portion of DataStax Enterprise is our world-class support. This term covers all the things from sales engineers, solutions architects, support teams, QA, and the rest of the engineering pool, since each and every one of us is committed to making a world-class experience. So now you have at your disposal a groundbreaking database built with open source components that is fairly priced, along with a resilient, searchable, firewalled suite that is free to use, develop, and go into production with without holding an empty wallet. Because we know that you'll be successful, and because we want to see this world change, because we want to see what you can do. So all in all, in conclusion, we're here, we're growing, we want to help, we want to expand, we need you. Let DataStax story also be your story, our story. Thank you very much.
Thanks, Joaquin. That was amazing. I think you set the Guinness Book World Record for number of slides in under 5 minutes. And you even came in 30 seconds ahead of schedule. Up next, we have Scott Andreas from Boundary. I'm going to turn it over to you and knock it out, but probably not as many slides as him.
Wonderful. Thanks so much. It's great to see everyone. My name is Scott Andreas. I work for a company called Boundary. At Boundary, we think of monitoring as an analytical problem. This is kind of a subset of what we think of together and why many of us are here, the slow swallowing of everything as an analytical problem when we look at what we can do with data. So at Boundary, we accept high-velocity network flow data that tells us what's happening in users' networks across their data clusters like Cassandra, or across their webheads, or as they talk to public mobile networks. This means right now we're accepting a stream of about 1.03 gigabits a second of data from our customers. That's a lot of data flying at our face. In fact, it represents about 2 million flow halves a second that we process in our analytics engine. So this means that we've got a problem like quite a few other people. So we have to wonder, like, what do we mean by analytical when we speak of the world being swallowed up by these analytical problems? People speak of big data, but it's kind of silly to think about it without context. So we can think of data in terms of volume, just the sheer amount of it that we have to store. We can think of it in terms of velocity. How quickly is it coming at my face every single second? We can think of it in terms of importance, like, is this a bank transaction? Can I lose a few here and there, or do I have to have every single one and record it faithfully? So we can think of this kind of like a spiderweb diagram, like we might have importance, and then velocity, and then volume over here. And the trick of getting out of a large data problem alive is, of course, finding ways to separate these concerns and make them smaller problems that we can solve in discrete systems that can fail without breaking everything together. So for us, that meant high dimensionality acceptance of data up front and reducing that quickly as a stream, and then high velocity compaction-free storage in back, which is part of the reason why I was particularly intrigued by Kairos. For us, being able to store that data and just drop it once it's expired is pretty critical. So we use all of this data that we accept from our customers in terms of packet flow data to build these dashboards that show folks things like the throughput that their traffic might be seeing, or changes in packet loss, and changes in the round trip time of their applications. All this is pretty critical for monitoring large data systems. So many of us who joined to start Boundary are actually from companies that have previously worked in large data systems like Urban Airship, FormSpring, and others. So we also use this to build a graph of what's happening. We think of our infrastructure in terms of clusters of servers that are hooked together, like our load balancers or our analytics engine. I'm realizing now that every single one of our services has some cute, cheeky name, and that's all up here on the screen in front of you, so sorry about that. But other companies like Netflix, I'd like to thank Adrian Cockcroft for showing yesterday what they're evaluating Boundary to do. Companies will use things like Boundary to show their communication across availability zones and cross regions when planning global deployments of their data architecture. So this is also a fantastic way to keep track every single second of what terabits a second of traffic are doing in different folks' infrastructure. So we then marry this high-velocity streaming data with event data, things that are happening in Nagios, Munin, Pingdom, anything that speaks email can send information up to Boundary, and we use that to build this nice-looking dashboard of what's happening every second. We'll also pull in data from other sources like Amazon's EC2 feeds, Rackspace's feeds, and get a feel for what's happening in other infrastructures, along with these high-velocity time series dashboards that show folks what's happening. So this is me trying to analyze a bug at a conference. I was trying to figure out what's happening because every 5 minutes we would see this huge spike happen along with this sort of jittery pattern. and clocks starting to skew in our infrastructure. So anytime time starts to bend, that's like a pretty serious issue. So here I am at this conference getting ready to present, but I pull out my laptop and then SSH into the boxes to see what's happening. And as I SSH into these boxes, I think, okay, I just want to know what's happening on this box and what unusual is happening each second as this anomaly starts to appear at the far right here. So then what I started to see while watching PS in a while loop was that Munin started popping up here and then forking all of these plugins to run to check our different metrics. So it would run things like Ruby processes and Perl processes, and in the end forked like 40 different interpreters every single second. And it turns out that just that process of spawning 40 Ruby interpreters a second to check all these metrics greatly disrupts the operation of the system as a whole. So we're not even looking at the metrics that our collector is passing through. We're actually looking at the disruption and the failure of our collectors to participate in their distributed system because of what else is happening on the host. So Boundary is not just about network data. It's about application flow data and how those applications are affected by different pieces of infrastructure that are running on your machines. We also look at this in terms of deployment. So when we roll out new infrastructure, we can see right away as we put load on something, right here we introduce something bad. We realize right here, oh, there's a problem and we can't really fix it, so we need to roll back. And in the space of less than a minute, we've saved ourselves from taking down production. If we compress this into a 1-minute level view, we just see this one single data point, which wouldn't have given us that time to react to the problem. So if you're operating a large-scale analytics architecture or any distributed system with more than 100 boxes, we greatly encourage you to check out Boundary. You'd be in fantastic company with companies like Urban Airship, GitHub, Basho, and Jive, and a bunch of other folks who we work with. Deploying Boundary is super simple. You can just use a bash script or roll it out to every single box you've got with Puppet or Chef right off the bat. And beyond that too, like many other folks here, we're hiring and always looking for talented young women and men and older women and men and people from all walks of life to join us. So please come check us out. I'll be standing outside. It'd be wonderful to talk to you more. Thanks so much.
You did not set the record for number of slides, but you did come closest to the wire, right down to 0 seconds. I was hoping it was going to get cut off for someone. Last but not least, we have Jeremy Hanna to talk all about troubleshooting Cassandra.
So let's go back. My name is Jeremy Hanna. I work on the support team at DataStax. So I'm confronted with a lot of different problems and scenarios and contexts of where Cassandra is deployed or where DataStax Enterprise is also deployed. And I just wanted to stand and give a handful of just really basic suggestions on configuration of Cassandra so that you can avoid a lot of the headaches that we see on the support team. I'm not going to cover all of troubleshooting, but and then one other point that I'd like to make before I get started, I don't think it can be underestimated. A decent and very similar test environment to your production environment. I've been there when you have a prototype that you're trying to work through, a lot of deadlines, and that prototype test cluster goes into production and you're left with nothing else. The data's large. It's hard to set up a test environment that's remotely similar, but it's well worth it. It's well worth it for testing upgrades, for testing changes, testing configuration. So beyond that, just some specifics. Java. Latest 1.6 Oracle JDK. Don't go with OpenJDK in production. It's fine on your dev laptop, but in production, we definitely recommend the latest 1.6 Oracle JDK. When your Cassandra server is starting, make sure JNA is enabled and locks all the memory, or is able to do the mlock all, so that you don't run into performance anomalies. So that message is on startup. You should see that. Garbage collection. I mean, that's the bane of every app server's existence or any server that's based on Java. But in Cassandra, they have some helpful log messages that will indicate what type of GC problems that you're having. So you might see pauses that are more than a second for either parnu or concurrent market sweep. You might see warnings that your heap is a certain percentage full. If you're over like 85%, then you probably want to do some tuning there. And so some of the things you can do about that, I'll mention in a little bit, but you can enable the GC logging in Cassandra env and .sh, and you can correlate the GC logs with the system logs where you've experienced a lot of long pauses, so you can get a lot more detail about what the garbage collector is really having to do. For instance, if you're having to traverse a lot of tombstones, it might have certain characteristics in the GC log. Another thing you can do is just take a heap dump, open it up in the memory analyzer tool, or something similar, so you can see what's dominating your heap or what's going on in a snapshot form. And then the last thing, you can use Op Center. The free version of Op Center has GC graphs, so you can track over time and correlate when you see the GC spikes to see if there's any correlation that you can find there. Going along with that, for memory, the max heap size in Cassandra env.sh, we recommend people go as low as they can, because GC pauses are going to slow you down. And so it requires some testing, but generally we recommend that you don't go over 8 gigabytes. Some people can push that a little bit further, but once you get higher, the CMS pauses get to be very noticeable and cause other problems in your system. The heap new size, we need to probably update the comments in the Cassandra env.sh. Regardless of the number of cores, don't go over 800 megabytes, or else you start to see a lot of longer par-new pauses. Disable swap. Be careful with off-heap, or even with off-heap cache, because it has to be deserialized within the heap. So large rows will have to be deserialized into the heap. Some troubleshooting tips. There's some query tracing in 1.2. Narrow down your bottlenecks with things like IOStat, top, and things like that, and VMstat. Diagnostics and Op Center 3.0 or 3 forward will give you a whole slew of information. And there's another note that I'll post on Twitter.
And we got our one cut off. For such a nice guy, I'm so sorry that it happened to you. So first of all, one more big hand of applause for all of our lightning talks. Thank you guys very much. This room is getting ready to be used by Eddie Satterley to talk about Splunk and Cassandra, so I highly recommend sticking around for that. Eddie's a very smart, great speaker. But if you want to talk to anyone who gave a talk, they'll be right outside that big black curtain and would love to talk to you. Thanks again, everyone.